All right, good to go. This figure shows the 4 phases of the myocyte stimulation. This where we were? This was where we were. Okay, so here's a graph that also shows on the timeline what happens during each wave of the heart. I think the last I was on was the T wave and QRS. So QRS, this is when, the reason why this is so tall is because there's so much more electricity that is going through this compared to these. There's a lot more of a charge happening. Why is that? Because this is the biggest part of the heart. What is the biggest chamber of your heart? Not your atrium, but your ventricles. Your ventricles are the biggest part that pumps all of that extra blood in through your heart. One ventricle pumps into your lung, and then the other one pumps to the rest of your body. That's the powerhouse. Sometimes after the T, if you have hypomagnesia or other electrolyte imbalances, you might see a little bit of a U wave. Very difficult to pick up on. It'll be very subtle. So we have down here where the heart starts at that negative 90 millivolts. Whenever it goes through the first phase of the heart, this instance between the P and the PR getting all the way to the QRS, Q, P to R, this is when we lose negative millivolts. That is the first depolarization portion of the heart. Then once we get to this point, it completely drops off and fires almost all the way to positive 30. And then it comes back down, phase 1, right here, and drips all the way back down to the threshold potential of the T wave until we repolarize, go back to normal. We're at negative 90 millivolts. Refractory period. Period during when the cell is depolarized or in the process of repolarizing. It consists of 2 phases. First half represents the absolute refractory period. This is the period of time from which phase 0. Do you keep ducks in your Jeep? Who is this? The first half represents the absolute refractory period, a period of time from phase 0 in the middle of phase 3, in which the ventricles have not sufficiently repolarized to enable another depolarization. Second half represents the relative refractory period. Middle of phase 3 to the beginning of phase 4, which indicates that some cells have repolarized sufficiently to depolarize again. The conduction system. Specialized conduction tissue made up of specialized pacemaker cells. The pacemaker is the area of conduction tissue in which electrical activity arises. It sets the pace for the cardiac contraction. Dominant pacemaker in the SA node, your sinoatrium node, lies at the junction of the superior vena cava and the right atrium. First the chamber of the heart, and then the vein that brings back all the blood from the rest of your body, the largest vein that you have. So right at that junction is where your SA node keeps your first pace with your heart. You have 3 of them. In about 0.8 seconds, the electrical impulse generated in the SA spreads across the atria, advances through these internodal pathways. AV node, this is 2 out of 3 of your pacemakers. The AV node is located in the floor of the right atrium, behind the tricuspid valve, near the